multiply negative x squared by to get positive x squared? Negative 1. So I'm going to put, and it doesn't really matter where you put it. Some people like to teach it where, like, you line it up, like, you know, if your x squareds are here, your x's are here, then, you know, 1 is here. So what were we going to multiply by? Negative 1? You put negative 1 on top of the negative. That's not necessary, but you can do it that way. What's negative 1 times negative x squared? X squared, so you put that here. What the hell? Negative 1 times x is, so negative 1 times x is negative x, so I put that right here. And that's it. Now I come through here, and what do you do with this? Subtract it. So that changes the signs. It makes this minus x squared, and it makes this plus x, doesn't it? And then go and add down. What would you get? X squareds cancel, right? Just x plus 1, right? And now you ask yourself, what do I multiply negative x squared by to get x? And that's where you stop. As soon as the power on the outside is higher than the power here, on this x down on the bottom there, as soon as that power out here is bigger than that, you're done. So this is our remainder, isn't it? That's what's left over. So the way you write that is like this, up on the top, plus your remainder over your divisor. That's it. Now, you might be saying, why in the hell would I want to do that? Well, take Cal 2, and yeah, you'll see. Where were we? I kind of got sidetracked there. Now we want to do fog. F of g of x. So this means we're going to take the f function and we're going to plug in the g function. That's the definition of composition, right? So I'm going to put f, and inside of f, I'm putting the g function. What's the g function? X minus x squared. So that's going to be plugged into f. So everywhere I look at the f function, and everywhere in the f function that I see an x, I replace it with that, right? So it becomes what? X minus x squared squared, then plus 1. And then you'd have to multiply that out. What's x minus x squared squared? Is that x squared minus x to the 4th? No. You have to FOIL it, right? Could you FOIL that on your own? Good. Should become x squared minus 2x cubed, I think, plus x, plus x to the 4th, plus 1. Pretty sure that's what it is. Now, how many of you were taught fog and Goff? No? Fog and Goff, that cute little, okay. How about this, though? What would g of f of g be? I mean, there's nothing saying that you can't have composition repeated. This would mean g goes inside, well, we have g inside of, let's see, f inside of that is g of x. So we had g, g, f, g. So g, g, f, g. So g goes inside of what first? F. That answer goes inside of g, and that answer goes inside of g. Okay, that's a bonus. You can turn that in next class. All right? It's tedious algebra in there. But put that all together and expand it all out and turn it in for bonus if you like bonus. It's just to show you that you can have functions composed with themselves and with other functions. All right, let's now not do 1.2.6 because of time. Let's go on to note 1.2.7. What we're interested in this class is not what we were just doing. That was just to kind of remind us how to do the algebra and arithmetic. What we want to be able to do is called decompose a function. So I'm starting out with this function m, capital M, of x equals sine to the fifth x squared plus x. All right. So the instructions are find the functions f, g, and h such that m of x equals f of g of h of x. So we want to find f of x, g of x, and h of x. So we're actually working backwards. Somehow this capital M function is a function inside of a function inside of a function. So what are they? Do you all see three functions here? What are the three functions that you see in this, if you even do? Sine of something is a function. Say again? Sine would be, well, before we get to which one is which, let's talk about the functions that you do see. You see sine of something, what else? X squared plus 1 is a polynomial function. What else do you see? What does that little 5 mean? Doesn't that mean raise it to the fifth power? Doesn't having a 5 right here on this sign mean raise that whole answer to the fifth? So this really means, like, imagine that you were x, okay? What's the first thing that would happen to you if I plugged you into this? You get squared. Then? Get added to 1, and then? Well, take sine of it, right? So then you take sine of that, and then finally raise to the fifth power. So if we're looking at functions here and we're trying to decompose this, there's two ways to look at it. You start from the outside and work your way in, or you go from the inside and work your way out. We, because of where we're going, are going to start from the outside in. So we want to start from the last thing happening and go to the first thing happening. So what's the last thing that would happen in this problem? Raised to the fifth. So I'm going to put here for f, x raised to the fifth. So now I'm going to kind of scratch out the fifth power. What would be the next thing as we went in? Sine of something, right? So sine of x. So now I'm going to scratch out the sine. Now what? X squared plus 1. So how would we check it? We take h, right, and plug it into sine of x. So I plug it into g, right? And that would give me, well, I'm trying to jump too far. Let me write down over here, f of g of h of x. This right here, f of g of h of x is this, f of g of h of x. H of x goes in here, so it becomes f of g. I'm just checking right now, right? H of x is x squared plus 1. Take x squared plus 1 and plug it into g. What would you get? Sine of x squared plus 1. And now take that and plug that into f. Sine of that all raised to the 5th, right? So I just put the 5 there. So that checks. It depends. I think you're asking me this. Is this sine of x squared plus 1? I don't know why I'm having so many issues with my writing here. Did y'all see that warning pop up earlier about changing my color scheme? I should have changed it because I think my computer is running at like maximum performance right now. Let me see. Where is it? Performance. That's not so bad. It's peaking out the certain spots. Okay. Okay, so the question was, is this correct? Well, what do y'all think? What's wrong with this version? Yeah, this would mean x gets squared first, then what? Plus 1, then raised to the 5th, then sine. So that would not give you the same result. To make that correct, you would need this to be in brackets or parentheses. You can do either one. Okay? Good question. That's why we put the 5 here, is so you realize that that's the last thing happening in that problem. Well, in this particular one. All right, that's it for those notes, but I want to see if you can do one on your own here, okay? Or with each other. So I'm going to give you a capital M, and I want you to try and break this down. Capital M of x equals 4th root tangent sine square root x plus x. Find f, g, h, and k such that m of x equals f of g of h of k of x. So I'm telling you that there's a function inside of a function, inside of a function, inside of a function. 4 of them. Can you determine what they are? Remember I said work your way from the last thing happening back to the first. Or work your way from outside in. Okay, go ahead. I just realized I didn't record that last thing that I did over here with the U, V, W, T. So, oops. If you have it and you want to ask, want me to come by and take a look, I will. Or if you have a question. So you got it in, what, 4? All right. You can go one more. Yeah. Oh, and try and do it with the way I did it with UVW also. So you can do it either just the UVW type way or both. But I want to make sure you can do the one on the right instead. So T Yes. So you're saying it would go like from here to here.